Welcome to another session of INF 164. So I'm not feeling well, but I hope this session goes well. So in this session we are going to start about object-oriented programming. So when it comes to object-oriented programming, we have two important things. So we have types and instances. So a type is a concept from which an instance is created. So we create an instance from a type. So a type is an abstraction. An instance of that type is concrete. So a type is just an abstraction, or in simple terms you can say it's a description. Then an instance is concrete, so it's a real thing. An instance is a real thing. A type is just a description. So let's look at examples. So the word clock is a type because it defines the general concept we are familiar with. As an example, let's say the clock in John's office. So this is a type, it's just an abstraction, it's just a description. So we have many clocks, but they have one thing in common. They are clocks. It can be a watch, it can be, but it's just a concept, or it's just a description. So we can have a clock in Sue's office, or the clock in a train station, in train stations. These are instances of the type clock. So all these clocks, they are just instances of the clock. So it will make sense soon. So as an example, we can also consider a circle. A circle is also a type. It's just a description. We can draw circles with different radii as instances of that type. So we can have multiple circles, but those circles can have different radiuses. The word person is also a type. As an example, John, Susan, and Vince are instances of the type person. So person is just a general description. So it's just a word that describes a person, but we can have actual people that come from the person type. So let's see. So as an example, we have the type circle. So this is our type. It's a description. Then from this type we can have as many circles as possible. So this can be circle 1, which has the smallest radius, circle 2, which has a larger radius, circle 3, and circle 4. So these circles come from the same type, or they are of the same description. These are instances of the circle class. So what's the relationship between a type and instances? So the relationship between a type and instances is a one-to-many relationship. This means we can have many instances of the same type. As an example, you can see that we have one type, but we have multiple instances or objects. Then any instance we encounter in this word has a set of attributes and a set of behaviors. So how do we model these attributes? So in real life, an attribute is a characteristic. It's a characteristic ascribed to an instance. As an example, an employee has a name. They might have an address, the position that they are working, then the salary. Then another example, we can have a student as a type, because the student might have a name, the course that they are doing, the year of study, and many attributes or characteristics. Then how do we model behaviors? So a behavior is an operation that we assume an instance can perform on itself. As an example, a student can walk, they can eat, they can cry, they can do whatever they want. So this is just an operation, and we model behaviors using what? Using methods. Then let's see the next part. Then now we can move to classes and objects. So a class is a piece of code that describes an object. So this is very important. A class is just a piece of code that describes an object. It specifies the data an object can hold, which are your attributes and properties. It also specifies the actions that an object can perform. These are your methods. Then you can think of a class as a blueprint that can be used to create a particular type of object. So that's mostly, so a class, it specifies the data which are modeled by attributes and properties. It specifies the actions that the object can perform, which we model using methods. So you can think of a class as a blueprint that can be used to create a particular type of object. So as an example, let's say you have a house plan. So we know that a house plan, you will draw that on paper, or nowadays you can use software to draw a house plan. So let's say in your house plan, you have a bedroom. This is your bedroom. Then you have a living room. So let's say this was your house plan. So this is just a description of a particular house. This is just a blueprint of like houses, or of specific houses. Then from this description, we can actually create we can create multiple houses or physical houses. So this house is different from this house, but they come from the same description. What they have in common is that they have a bedroom, they have a living room, and they were created using the same house plan. You see that from a description we can create multiple houses. So this is just a description. These are instances of the house plan class. So instances of the house plan of the house described by the house blueprint or by the house class. Object is instance of a class. So in summary, we can say a class is a description, then an object is an instance of a class. So examples of classes, we can have a student class, we can have a dot class, we can have a character class, we can have rectangle class, like we can have many classes or many descriptions. So what are the characteristics of a student or attributes? So a student can have a name, student number, year, then modules. What can students perform? They can party, they can go to campus, they can date, they can cry, they can sleep. So these are the attributes and methods that describes a student. So this is the student class. So let's consider the dog class. A dog can have a name, age, gender. Methods, it can bark, it can sleep, and it can play. So these are the attributes and methods describing the dog class. Then we have the character class. A character might have a name, health, date of birth, strength, and coins. What are the actions or methods they can perform? They can run, they can fight, they can block. Then we have the rectangle class. So a rectangle, the characteristics of a rectangle is that they have a length and a height. So methods that they or actions that we can perform on this rectangle class. We can get the area, we can get the perimeter. We can get the perimeter. So the next thing that we have to consider, this is all. Then how do we actually create these classes? So I'm going to go to, I created a new project. Then you go to our project. You go to, it's project. Then you say add class. Then let's say we wanted to model a rectangle. So here for the name, I'm going to, I think I made a mistake. Let me delete or rename actually. So we are going to rename this to rectangle. Then we are just going to say okay. So you see by default, let me try to zoom in. The class is internal. So this will cause issues when you have multiple forms. So it's a good practice to make this class public, like this, so that when you are working with multi-form applications, you don't have issues in accessing the objects of this class. So the general structure is this: public, then you specify the class keyword, then you specify the name of your class. This can be student, it can be anything. Then we said a rectangle has a length and width. How do we handle those ones? So for now, I'm going to do it sort of the wrong way. Public double, then I'm going to say length. So it has a length. A length is a double because you can have 1.5. Then we need the width. So these are the attributes. So these are the attributes of the rectangle class. Then after creating the attributes, we can, so these are public. So the public specifier means that these attributes can be accessed outside of this class, the rectangle class. So in general, public attributes can be accessed outside a class that created them. For example, in this, if I double click on the form, in this form one class, we can access those public attributes. So they can be accessed anywhere if we make them public. So in memory, we are going to have something like this. So we are going to have rectangle, which is just a description. Then this description, a rectangle has a length and it has a width. So this is just a description of the rectangle class. This is not an actual rectangle, it's just a description. That's how we view this. But to create object, you need one method which is called the constructor. So what is a constructor? So a constructor, so this is a special type of method that is used to create, and then I can say instantiate, or you can say initialize, then objects. So you cannot create objects without having a constructor. So what are the properties of a constructor? So one of the most important thing is that it has the same name. So it has the same name as your class. Then the other property is that it doesn't return anything. Or you can say it doesn't have a return type. So it doesn't have a return type. So those are the characteristics. In this case, we want to create a constructor that will initialize or instantiate our length and width. So you are going to say constructors, then I'm going to say public. It's always public. Then in this case, the name of the class is what? Rectangle. So it can receive something or it can not receive anything. So it is used to initialize our rectangles when we create them into like sort of a default length and width. So let's say the default is 0, then width is also 0. So when we create our object, by default is going to have this length and width. So we call this a default constructor. Notice that the method doesn't have a return type. It's not like public void or public int. No, it doesn't have any return type, and it's always public. Then again, you can let the user to decide what the default values must. So you are going to say rectangle, then you are going, in this case you are receiving the length. So I can say double L double width, then I can say length equals to L, then width equals to W. So this is back to normal methods. So this method receives two values, then it initializes our length and width to those two values. So we call this an overloaded constructor. So this is an overloaded constructor. Then what about the methods that we can create, or the actions? So the first method is to get the area. So the get area method must return the area as a double. So I'm going to say public double, then I can say get area. Then it doesn't receive anything because we are going to use this length and width. So we are going to maybe return, then I can say length times width. As easy as that, or I can do it step by step. Double area equals to length times width, then return length times width. Notice that this method doesn't receive anything because it's going to use these attributes. Remember, when we create an object, each object is going to have its own length and its own width. Then we can do the same with the parameter. So public double get perimeter, then it's going to, it doesn't receive anything because we are going to use those ones. So to get the parameter, we just say 2 multiplied by the sum. This is basic math, so I'm sure all of you did pure maths, so this is not difficult. Or you can do it step by step, define a variable perimeter, then return that perimeter. So this, at the end, this is just a description. It's not an actual rectangle. So how do we create actual rectangles from this class? So this class is just a public class. It has these attributes. It has this constructor which is used to initialize and create object. Alternatively, you can use this constructor which receives two values. Then it initializes the length and width to those two values. Then the methods, we can calculate the area, we can calculate the perimeter. So how do we actually create these? So I'm going to go to the main form. Maybe add things. Maybe labels. And buttons. Then let's add a text box. So what did I do now? Control Z, then Control Alt X. So text box. Then I'm going to copy these. Then I'm going to rename these. So this one is going to be length. This one is going to be width. This one is going to be maybe create. Then we can have another button for display. Then we can give them names. So this one is going to be btn display. This one is going to be btn create. This is going to be txt length. This one is going to be txt width. So let's say when we click this create, it's going to create an object. So I can make this object global, local or global. So if we make it global, so the general syntax of creating an object, we are going to say, okay, our object is going to be, so you just put the class name. So this is the class name, then you put the object name, then you say equals to new, then you call your constructor. Where is the default constructor or other constructors, or the overloaded constructor? So in this case, our class name is a rectangle. Then I can name it, for example, R1 equals to, then I'm going to say new. Then I have this, I can either use this default one or I can use the overloaded one. So in this case, we are receiving values from the user. So I'm going to say new, then rectangle. Then where do we get the things? Let me close here. So this one receives length as double and width as double. So where do we get length and width from the text boxes? So instead I can do it step by step by saying, okay, double length equals to then convert to double because we are getting it from a text box. Convert to double, then txt length dot text. Then where are we getting the width? Width equals to convert to double txt width dot text. Then here on the constructor I have to pass the length and width like this. So this is just a method call. We are calling the constructor. We are creating a new rectangle object using this length and width that we got from the text boxes. So if we go here, let's ensure it starts with length and then width. So did we do that? Yes, we have length and width. So now let's see how this works in detail. So when we say new rectangle, let's say the user enters, then let's just display let's display a message. Just to tell the user. So let's see how this works. So let's say we enter 2 for the length and 3 for the width. So when we click create, it's going to go here. Length will store 2 and width will store 3. Then we are going to create a new rectangle object that receives 2 and 3. So in memory, we are going to have our R1. This is an actual object. So it has what? It has a length, actual length, and it has actual width. So let's see the default one, 2 and 3. So we called this constructor that receives 2 and 3. So it's going to go to the rectangle class and check. So it's going to set length to this 2, width to this 3. So we are going to have this class having 2 and 3 as the length and width. So we successfully created the object. Notice that this is no longer a description, it's an actual thing. You see that the description didn't have actual boxes because this was just a description. But this one is an actual object. It has an actual length and an actual width. So in this case, it's going to be like that. So if I click run or create, it's going to show me that the object was created successfully. Now when we display this, it must display the properties of this rectangle. It must display the length, the width, and the area and perimeter. So I'm going to double click on this. Notice that we want to access this R1, but this R1 is a local variable, so it's defined inside this method. Instead, we can define R1 as a public variable, so it doesn't change anything. It only changes, the only thing that changes is that we can access this R1 anywhere. So by default, we are going to set it to null. Null means to nothing. Then we are going to remove this so that we use the actual R because we created that object here. then this doesn't change anything, it's going to work the same. The difference is that we can access this R1 anywhere. So for displaying, we want to display the length. So message box, let me do this picture. We can say string output equals to. We can also check first if our object, if R1 is not equals to null, then we can display, otherwise we can't because it's nothing. Only when the user clicked on this create button, we will create this R1. We will display the properties of R1. So we are going to say string output equals to, let's say, we are going to say length is equals to, then let me close here. So length equals to, then I'm going to, how do we access these? So to access anything, you just say R1, then say dot length. So it's going to, when you say R1 dot length, it's going to refer to the length of R1. So R1 dot length is going to refer to this R1. Then if I say R1 dot width, it's going to refer to this width. Remember, with a form, if you have like a form, maybe you have a text box, whatever, then if I say this dot txt what, I'm referring to this text box. So it's a similar situation, but here we are referring to this length and width. Even for multi-form applications, we were saying f2.txt what, where f2 is an object of the f2 form. So this is the same thing. When I say r1.length, it refers to this length of r1, which is 2. Then if I say r1.width, it's referring to this box in general. So it's referring to this box. So let's see. To display it, we are going to say r1.length. Then we can say width equals to, and r1, actually r1.width. Then we can add a new line. Then we are going to add a new line. So here I'm going to say output because out is a keyword, so it won't work. So now I can say output plus equals to, now I need the area and the length. So area, so I'm going to say area equals to R1. How do we call the method? So the method is get area. You just say dot get area. So let me see. So I'm going to say R1 dot get area. Then I successfully called the method. Then maybe I can add a new line. Then I'm going to say output plus equals to. So I'm going to say output plus equals to, then I can say perimeter, then equals to, then I'm going to say R1 dot get perimeter. Then this is the last thing, so I can just close. So you can use the normal string concatenation, or you can use this dollar thing. It's the same thing. So let's see how this works. So I'm going to create a rectangle maybe 10 by 20. Then if I click display, because I haven't clicked on this button, our R1 by default is what? Let me go to the form design. Our R1 by default is null. So let's note that. So our R1 doesn't have any, so it's null, because that's the line of code that initializes R1. Then if I try to display, it's going to check, is it not equals to null? So basically is null not equals to null? No. So this is going to be false. So we are going to ignore this. Here we can actually do an error message, else message box.show. Then we are going to save as create an object first. Like that. So let me close this. Let's say display, so it must give us an error. So even if I say type 20 and I don't click create, it's going to give us an error. Then if I click create, successfully created the object. So I'm going to go here. So we know that it's going to create R1. So R1 now it's no longer null when we are creating a new object. So R1 is going to be this actual rectangle with a length and with a width. So our length is 10, our width is what? It's 20. So this is our R1. So we successfully created the object. Now if I click display, it's going to go to this it's going to go to this R1 is not null, it's not nothing because we created a new rectangle. So it's going to output R1.length, it's going to output R1.length refers to this 10, then it's going to go to a new line, R1.width is go before going to a new line, R1.width, then you know that R1.width is going to be this. Then we are going to R1.getArea. When we go here on the get area, it returns length times width. Our length is 10 and our width is 20. Then we are going to say get perimeter is going to be 2 multiplied by 10 plus 20. Then if I click display, or where's the form? If I click display, let me see. Did I click create? I didn't say message box or show. Yes, I calculate the output, but I didn't display the output. So let's see now. So it's the same story. We are going to say 10, then 20, then we are going to say create. Then when we say display, it's going to show the properties of that rectangle. Then I think I made a mistake on the parameter. That one was too large. So it's plus here. So we are going to create, then we are going to display. So yeah, now it's correct, because parameter is the sum of all sides. So we have 2 times 10, which is 20, plus 2 times 20, which is 40, which is 60. Then the area is just the product. So yeah, that's how you create objects. And also here you can use the default constructor. So here if you use the default constructor, so let me just comment this. So with the default constructor, just see R1 equals to new, then rectangle, like that. So this is going to create the default rectangle which has 0 length and 0 width. So if I say run, then even if I enter things, it doesn't affect. So if I say display, you see everything is just 0 because it's the default constructor. Then for the default constructor, we can add an edit. So we are going to call this edit. Then if I double click on this, it must edit the length and width to whatever the user enters. So if I say r1.length equals to, this will change the length of r1. When you use equals to, it's going to change this to whatever value. In this case, we are getting this from the text box. So I can say to double txt length dot text, then r1 dot length is equals to convert to double, then we are going to say txt with txt is the text. So it's going to change the width and the length of the rectangle based on what the user enters. So if I run this now, so we know that if we say create, it's going to use the default constructor. Since I commented that part out, I use the default constructor. It's going to create a rectangle with 0 values. Then if I say edit, I have to enter values, value 2, 4. It's going to create a 2x4 rectangle. I mean, even if I click here, it won't affect. I have to say edit. So edit is going to change those zeros to something. If I say display, now we have something. So this seems good so far, but we have an issue. So these public values can be accessed anywhere. This means anyone can change our actual attributes. So normally we don't want that. So let me confirm. So normally by default we want these attributes to be private. So we want to make them private like this. Then I'm going to say private. Normally when you make them private, you just put an M So you say m length like this, then you say m width like this. When you make them private, it's up to you, but it must be something like that. So m length, then here I'm going to say m width. Even here it's just m length, then m width. So here we have m length, then here we have m width. So I'm just changing the variable names here. Even here we have m length, then here we have m width. Like that. So these are private. Private means they can only be accessed in a class that created them. The reason we make variables private is because of we want controlled access. So this allows you to control how and when data is accessed or modified. Security, in this case for security purposes, this helps in protecting sensitive data from unauthorized access. So yeah, that one of public was good, but we don't usually do that. We don't do that in general. We have to make those variables private. So now, if we go here on form 1, we must get errors because we changed these. So if I say m length, this is not going to work. Even if I say m width, this is not going to work because you see rectangle.mLength is inaccessible due to its protection level, just because we made it private. So how are we going to access those private variables then if they are private? That's where properties come. So that's where properties come. So what are properties? So a property for me, I can say, is a clever way of accessing private variables or changing private variables. So you can use the normal definition, which is a mechanism that provides a flexible, it's a member that provides a flexible mechanism to read or compute the value of a private variable. So how do we actually create properties? So we want to create a property for each private variable. So we are going to say, in this case, it's length. So we are going to say public because we want it to be accessed. Then the return type, which is length, which is double. Then we want to specify the name of the property. In this case, we have the length, like this. Then we open this, then we end. Then there are two methods. We have the set and get. So you just remove the m. Now you just say length. Even if you did something like underscore, this is also valid. You can use any as long as they are not the same. So we have this length. Then there are two methods. We have the set, which is used to change the value. So in this case, we want to change the private variable m length to whatever value the user will enter. So we just say m length equals to value. That's the set. Then we have another one, which is get, which is used to get or to read the private variable. So in this case, we want to read this. So we are going to say return m length like this. So this is a property for which one? For m length. So instead here, you just say public, the return type which is double, then you give it a name. It must be different from the actual variable. So the conventional approach is that you can either use an underscore here, or you can just use m to differentiate between private variables and properties. So you have the set. So you just say m length, the private variable that you want to change, you just say equals to value. This means whatever value they will provide on the right, it's going to set that. Then we have the get. The get is used to read the private variable. So we have there, it's going to return whatever private variable, in this case it's length. So we are going to repeat the same thing. So public for the other one. So we have public, then data type is double, then m, we remove the m and just leave. Then we are going to say set, then in this case we want to change m width is equals to value. Then we want to get, so we just say return m width because we want to get the m width. So that's how you create properties. So you have to understand this. This is how we are going to do it. So instead of using private variables in the form, you are going to use the properties. So the property, just say m, in this case it's length. This is a property that we saw that side. Then here you just say width. Then here you are going to say length and width because you are using the properties width. So you see, it shows you that this is a property. You have the set and get. Also, you can use this shortcut, I guess. So you have your properties created successfully. That's how you create the properties. The working of this is the same as the other one. So if I run this one, then I say create, it's going to create R1 having a length of 0, by default a width of 0. Because of that constructor, so when I say OK, then if I say display, it's going to run this code. So it's going to say, it's going to check, is our object null? No. Then when we say r1.length, length will access the private variable m length. So it's going to change m length to what? It's going to access m length, which is 0. So here it's going to say 0. Then m width, r1.width is going to access m width, which is 1. Which is 0 also. Then it's going to display. So this doesn't change anything that much. So we still have, if I say 2, 3, then it's the same thing. If I say edit, it's going to change the length, which is a property and is also a private variable. It's going to change it to whatever the user enters and the width to whatever user enters. So it doesn't change anything much. So if I say edit, so if I say display, you have this. So note that we use attributes to access and to change private variables. We don't make variables public. or attributes public, we make them private always. For 164, maybe for 272, that's where you can make them protected when you're using polymorphism and inheritance. But for 164, you make things simple. You make the attributes private, then you add properties. So what's the next thing that we can discuss? The next thing is an array, I guess, of objects. So as a recap, let's say you have multiple objects. Let's say you have rectangle, you have to say new. Actually, let me do this. So you just have to say new rectangle 2 by 4. Then let's say you have another rectangle R2, which is equals to new rectangle maybe 3 by 6. So we know that these two lines of code, this will create a rectangle object R1 which has a length. So I'm going to use the properties length, which is 2, and width, which is 4. So this is our rectangle with these properties. Then R2 is going to be length, which is 3, and width, which is 6. So we have two different rectangles. So if I say R1 dot length equals to 10, it doesn't affect this R1 because R1 dot length is going to go to R1 and it's going to say its length equals to 10. So it's going to change this to what? To 10. Same with this one. If I say R2 dot width, it's going to go to R2, then it's going to go to what? To the width. Maybe I say equals to 12. It's going to change this to 12. Then, what if we have million rectangles? Now we need million lines of code to create these rectangles and to access them. So instead, we can use an array of objects. So we can use an array of objects. So an array of objects is just a list of objects. From last time we saw that we specify the type. To indicate that it's an array, you just specify this, then you specify the name, then you say equals to new, then you are going to say type, then you are going to specify the size. So if you forgot how arrays work, you have to review arrays. Then let's see specifically one-dimensional arrays. Fortunately for these, we don't have 2D arrays for them. So let's say we wanted to create 3 rectangles. So I'm going to say this, the type will be rectangle. Then I'm specifying this to indicate that it's a rectangle. Then I can say rectangles equals to new. Then I say rectangle. Then I specify the size. Notice that here we are not calling a constructor. It's the normal way of creating arrays. So we need a size of 3. So how do we visualize this in memory? So in memory, I'm going to have this rectangles array pointing to how many memory locations? 3. So I have 0, 1, 2. Then I have to specify. So by default, this is pointing to null. This is pointing to null. This is pointing to null. So to access, you just say rectangles, then you specify the index, for example 0. It's going to refer to this memory location which is null. Then if I say rectangles, then I say add 2, it's going to refer to this memory location which is null, and so on. What if you wanted to create objects from that array? So let's say we wanted to create an object at position 0. So I'm going to specify the name of the array, rectangles. Then I say 0, then I say is equals to new, then I specify rectangle. Then I can say maybe 2 by 4. Like that. How is this going to work? So let me do this. So I'm going to copy this. Then I'm going to paste it here. So it's going to go to position 0. Position 0 will no longer contain null. It will contain a new rectangle. So it's going to create a new rectangle which has a length property and a width property. So the length property is what? It's 2. Then the width property is what? It's 4. Then the rest is just null. Then we can continue the same process. To allocate at 2, we just say rectangles at position 2 equals to new, then we say rectangle, then we can specify maybe 3 by 6. So it's going to go to position 2. So this null will be removed. Then it's going to put a new rectangle. So this new rectangle has a length and it has a width. So this one has 3 by 6. Then we can repeat the process. So if I say rectangles add 1 is equals to new, then I say rectangle. Then I say 2 by 5. It's going to go to position 1 and it's going to create a new rectangle. So it's no longer null, it's going to create a new rectangle which has a length property and a width property. So this one is going to be 2 by 5. So 2 by 5. So we successfully populated our array of rectangles with actual rectangles. Now the question is, how do we actually access these rectangles individually? So let me copy and paste this. So copy, then I'm going to paste here. Then if I wanted to access these, I can do them one by one. I can say, for example, if I say, let me create it in code because it's easier that way. So let's add another button, copy and paste. Then let me put these ones one side. Then this one I'm going to name it array. So when I click this button, it must create an array. So btn create array. So again, for simplicity, I'm going to make my array a global variable. So I'm going to say rectangles. Then to specify that is an array, then I'm going to say equals to now. Initially it's an empty array. When I click create, it's going to populate. So new rectangle, then I specify the size. In this case we say it's 30. Then if I wanted to populate, so rectangles add 0 is equals to new, and I'm going to say rectangle. Then I can call the constructor. So let me refer to that again. So 2 by 4, 2 by 5. Then add 1 is equals to new. Then 2 by 5. Then rectangles add 2 is equals to new. Then rectangle 3 by 6. So this is just going to create the same array like this. You have this array of rectangles where you are pointing to different rectangles. So you have to understand this. Each rectangle has its own length and width. For example, let's say we wanted to display this in the message box. So if I say maybe string output equals to, then I'm going to say so length equals to, then I'm going to say that rectangles, so add 0. So if I say rectangles add 0, what are we referring to? We are referring to this rectangle. So we can say add 0, then we can say dot length to access the length. So rectangles add 0, dot length, it refers to that. So if I say dot length, it's going to refer to the first one. Then I can close there. Then I can repeat this with the width. Width equals to, then rectangles add 1, then dot width. Add 0. Then we can add a new line. Then I just repeat the process. So plus equals to, then I'm going to copy the syntax since it's just the same. So now we are just going to say add 1, then add 1. Then again copy the same thing. Then we are just going to say output plus equals to. Then now add 2, then you specify add 2. So you can do it one by one. Like this. So rectangles at 0 is going to refer to this. When we say dot length is this, 0 dot width is this, 1 dot length is this, 1 dot width is this, 2 dot length is this, 2 dot width is this. So that's the idea behind these array of rectangles. Then if I say create, actually I didn't display code.show, then I'm going to say output just for displaying the result. So when I say create, it's going to create an array of rectangles of size 3, then it's going to create a new rectangle on each index. So at position 1 you have a new rectangle 2 by 4, at position 0 you have a 2 by 4, position 1 you have 2 by 5, position 2 you have 3 by 6. So if I say array, it must display these. But what if we had million rectangles? How will we display that? So that's the next thing. How do we actually loop through this array? So we can use the normal for loop, or we can use the for each loop. So let's start with the traditional for loop. So traditional for loop. So we know how to loop through any array with the loop. So you just say for int I equals to 0, this means you start at 0, I must be less than the length of the rectangles array. So rectangles dot length, then I plus plus. Then you are going to do something. So you do something with current element. So that's the idea. And how do we access current element? In this case, it's rectangles at I. So let's see the working of this. Instead of doing it like this, I'm going to say, okay, for int I equals to 0, I will be less than rectangles. Oh, the length, then I plus plus, then we do something. So in this case, we want to add to the output. So I'm going to say output plus equals. Then I'm going to choose here. Instead, I'm going to copy this. Then I'm going to paste it here. So instead of using specific, I just use I. Then here we are going to say I. So that's how you loop through this array. So let me just put the message box down. Then let me remove this. Then I start with an empty string. So let's see the working of this loop. So when you start, it's going to say, okay, I is equals to 0. What happened? So when it starts, it's going to say I is equals to 0. Maybe I can try. Oh. So it's going to start at, let me just do this. I don't know why it shows this keyboard. Can't I extend this? Maybe. Okay, let me close this. Anyways. So let me remove this. So it's going to start I equals to 0. Let me just make it normal. So I is equals to 0. Then we check is I less than rectangles dot length. In this case we have 3. Yes. So what are we going to do? We are going to execute the code inside. So the code inside says add whatever rectangles I, which is 0 dot length. So this is going to refer to this rectangle. 0 dot length is going to refer to this. The 0 dot width is going to refer to this. Then after that it's going to increment I, which is equals to 1. Then we check is it less than 3? Yes, 1 is less than 3. So it's going to refer to rectangles I, it's going to refer to this. So now it's rectangles 1 dot length, which is 2, rectangles 1 dot width, which is 5. Then it's going to increment I will be 3. Then we check is 2 is 2 less than 3? Yes. Rectangles I, which is 2, it's going to dot length is this, dot width equals to this. So that's how you can loop through this array of rectangles. Then how can we loop through the same rectangle using the for each loop? So we can also use the for each loop to loop through that. So we can say, okay, for each, you know the syntax by now. So data type in this case is rectangle. So for each, then here I can say rectangle in the array name. In this case, it's rectangles. Then what I'm going to do something with rectangle. So instead here I can even use the for each loop instead of the normal or traditional for loop. So for each, then I can say rectangle, which is the data type. Here I can say like rectangle as rectangle. In rectangles, then I'm going to copy the same thing here. But with the for each loop, it's not necessary to specify. So here it's a rectangle because I'm using this, the variable name is rectangle. Then I'm going to use this rectangle.width. So we know that first iteration, our rectangle will store this. So if we say rectangle.length is going to say this 2, rectangle.width is going to be this. Next iteration, our rectangle variable will store this rectangle. So it's going to do this 2, then it's going to do this 5. Next iteration, our rectangle will contain this. So it's going to, if we say rectangle.length, it's 3, rectangle.width. So this is the other method we can use instead of the for loop. Can use the for each loop. Then here I can see the search bar section. Then if I run this, and and I say create array, it's going to be the same thing, basically. Now the last thing for this video is linking data grid view to an array. So let's add a data grid view here. Then I can say dbg, then rectangle, sorry. So we want to link our data grid view to our array. So how do we do that? Let's say during form load, if I double click here, not necessarily here, let me go back and let me go to the lightning there. So let's say during form load, we want to link our data grid view to the thing. We just say dbg whatever dot data source is equals to, then you specify the name of the array. In this case, the name is rectangles. So we have rectangles like this. So this is going to link your data grid view to your thing. Or let me not do it during form load. Let me do it here. Let's start with the form load one and see what's going to happen. I know something is going to go wrong with this one. Then I'm going to say create array. Even though we linked the form with our array, but it doesn't appear here. We link the data grid view with our array because an array is like when you link a data grid view to an array, it's going to try to link to the current state of the array. When the form loads, our array is null. So changes to the array, here we are adding items to the array, doesn't affect the data grid view. That's the disadvantage of using array. We will get to better methods. So instead of doing it during form load, I'm going to do it after creating the rectangles. So here I'm going to link my data grid view and the array. So if I execute this and I click run, now if I say create, it's going to link my data grid view with my array. And notice that the first, if you go up, you will see that these are the properties. If I go here on the form, this, so it links this to your properties length and width, not to your attributes. So it's going to start with the first property, which is length, then the next property, which is width. So this thing is automatic, you don't have to add manually. So it's going to link, you see length, width, then it's just going to link with the first rectangle, second rectangle, third rectangle, and so on. So that's the idea behind linking your array to the data grid view. The disadvantage of this one is that changes to the array won't affect the data grid view. So when we are using binding list, that's where we will see that changes to the array will affect the data grid view, which is a more flexible way of linking them. But yeah, that's the thing. I think that's it for this video.